Resistors are usually the most common component you will see on a circuit board, and their job is simply to resist the flow of current. Resistors are measured in ohms. We can identify the magnitude of the resistor by the colored bands along the length of its body. However, if you're colorblind like me, or you just can't be bothered with that nonsense, you can simply use a multimeter to measure the resistance. The background color of the resistor is blue, but you can get a tan colored version as well. The difference indicates the material it's made from and the accuracy to the stated value of the resistor. The blue resistors are metal oxide and are 1% accurate to the stated value, while the tan colored guys are carbon composite and they're 5% accurate. You may also notice a difference in size between resistors if you're looking at a circuit board. This indicates their ability to handle power, so generally the larger the resistor, the more power they can handle. So as you're going through your DIY project and you're starting to solder your components, there's one thing you've got to keep in mind the whole time, and a question you've got to always ask yourself before you go to solder, and it's, is this component polarized or not? So polarized simply means that there's a positive and a negative side to that component. Some components are polarized, some are not, but until you get very familiar with the different components, you've got to ask yourself that question each time. Resistors are not polarized, so it doesn't matter what orientation you insert them into the PCB with, but as we go through and look at the rest of these components, you will see that some are and some aren't. So always keep that in mind. A potentiometer, or pot, is a type of resistor whose value can be varied. A pot has 3 pins, and the outer 2 are connected to either end of an internal resistive strip, with the middle pin connected to a wiper which can be moved along its length. The position of the wiper is controlled by turning the pot's spindle. Potentiometers come in various forms, including dual gang, which means as you turn the spindle, you're changing the position of 2 wipers across 2 resistive strips at the same time. We have multi-turn for higher accuracy, and then we have faders, which can also be motorized. If you look closely at the top potentiometer, you'll see a small code, B104. The 104 refers to the maximum resistive value of the pot. We can translate this into an actual value by taking the first 2 numbers and multiplying them by 10 to the power of the third number. In this case, it would be 1 in 0, 10, times 10 to the power of 4, which is 100,000 ohms. The letter B refers to the taper, or the rate of change in resistance as you sweep across the element. B indicates a linear taper. We also have A, which is a logarithmic taper, and C, which is a reverse logarithmic taper. Here we have some capacitors. Capacitors store electrical charge and are commonly used as filters or to block direct current from passing some point in a circuit. We can see 2 types here. The small yellow capacitor is made out of ceramic and, like the resistor, is non-polarized. The other cylindrical capacitor is known as an electrolytic capacitor, and it is polarized, meaning that it has a positive and negative side to it. The positive leg is the long leg. You'll also notice that on one side there's a white band which indicates the negative side. There are also numerous types of other capacitor, including polyester, polyfilm, tantalum, paper and mica, to name a few. However, it is only the electrolytic ones that are polarized. Capacitors are measured in farads, but it's more common that you'll see them in the micro, nano or pico ranges. On the electrolytics, this value is actually printed on the side of the components, but with the other types, you'll find a specific code which you can then reference. Here we have 2 types of diode. The black one with the grey band is a common Schottky diode, and the other is a light emitting diode, or LED. Diodes are semiconductors and hence only allow current to flow in one direction, so once again, diodes are polarized. The negative side of a standard diode is denoted by the grey band. Sometimes you'll have an orange background with a black band, but it's the side with the band that identifies the negative side. And on the LED, just like with the electrolytic capacitor, we have a short and a long leg, with the short leg being negative. On the silkscreen of the PCB, the correct orientation of the diode will be indicated by a corresponding band, sometimes with a little triangle pointing towards it. For LEDs, there will generally be a plus or minus symbol to indicate the polarity. A transistor has 3 legs, and it works by taking in a small signal and outputting a large one. This property of transistors means they can be used for amplification or as a switch to turn a large signal on or off. The orientation of the transistor is critical. As you can see, there is a curved and a flat side to the body of the transistor, so this must match the orientation indicated by the silkscreen on the PCB. So far we've looked at individual or discrete components. However, thanks to the evolution of microtechnology, we now have at our disposal what are called integrated circuits. An integrated circuit, or IC, is a complete circuit made up of various miniature components encapsulated within a package, with its legs giving us access to different parts of the circuit. ICs can be analog, digital, or a mix of both, and usually require a ground and power connection. They will usually be designed for a specific purpose, such as amplification, logic operation, switching, timing, and there are even digital potentiometer ICs. It's usually good practice to solder an IC socket rather than the IC itself. This protects the delicate internal components from heat damage and also makes replacing ICs much easier. You will notice at the top end of the sockets there's a small notch cut out of it. This indicates where the end of the IC, closest to leg 1, should be situated. This end of the IC will be identified by a small dot or notch cut out of the top of the body. To identify the individual leg of an IC, first find this dot or notch and then move counterclockwise around the IC. If you want to find more in-depth information about an IC, for instance we have 3 TL072s in our image, you can type in this code followed by the word datasheet. This will bring up a document that will be full of information, including the pinout, which is a diagram showing what each leg of the IC is responsible for, a schematic of the internal circuit, suggested uses for the chip, including schematic diagrams, and every conceivable piece of electrical and mechanical data relating to the IC that you'd ever need. The power connector is what we use to transfer power from our system's power bus to the module. The connector on your power bus will be a male 2x8 IDC connector, and on your module usually a 2x5. You'll sometimes require 2x8 on the module side if the module also requires 5 volts. So something really important to observe here is the red stripe on one side of the cable. This identifies the -12 volt rail, and it's essential you connect this the correct way around both on your module and the power bus to prevent damage in your module. The male connector you can see is a typical safety connector found on a module and ensures that the cable can only be connected in one orientation. The small triangle you can see should match with the small triangle or the -12 volt marking on the silkscreen of your PCB. Another valuable tip is to always triple check your connections, especially when installing a module for the first time or soldering a power connector. It's so worth taking a little bit of extra time just to prevent what could be ultimately disaster. These are your standard Eurorack 1/8 of an inch mono mini jacks. They allow us to make connections between modules using patch cables. You can use any 1/8 of an inch cable, although there are patch cables of various lengths and colours, some that light up or glow in the dark, that you can purchase which are designed specifically for the Eurorack market. To secure your module to the rails of your system, you will need rack screws. It's becoming increasingly common for the standard width of the screw to be M3 or 3mm, although M2.5 is also still common. The screws you can see in this picture are Bafaco's own M3 Knurley rack screws.